Okay, so for section 3.4, cause and effect, it's going to be a lot of reading and a lot of just like understanding concepts. So the reasons for conducting a correlation study is to find evidence of the cause and effect relationship. So here are a couple of examples. Example 1, a health researcher may wish to prove that even mild exercise reduces the risk of heart disease. Okay, then you would have to do a correlational study between that mild exercise and risk of heart disease. Example 2, a chemical company developing an oil additive would like to demonstrate that it improves engine performance. So again, correlational study. And a school board may want to know whether calculators help students learn mathematics. Again, a correlational study between, of course, these two variables. Okay, a strong correlation does not prove, okay, this is important, does not prove that the changes in one variable causes changes in the other. So correlation does not necessarily imply a cause and effect relationship. There are various types and degrees of these causal relationships. Here's our first example. The relationship between two variables could be a cause and effect relationship. So the change in X produces a change in Y. Okay, and many times these relationships are clearly evident. So increasing the height from which you drop an object increases the impact of velocity. Okay, so yes, if you are going to drop something from the first floor of a building, it might not break, but the 10th floor of a building, it's definitely, the impact velocity is going to increase, so it's probably going to smash. Okay, similarly, increasing the speed of a production line increases the number of items produced, of course. Okay, now there's something called a common cause factor. This is when an external variable causes two variables to change in the same way. So suppose that a town finds that its revenue from parking fees at the public beach each summer are correlated with local tomato harvest. Here's the thing, people aren't going to the beach because the harvest is good, and there's not a good harvest because people are going to the beach. So there's not actually a correlation between those two things, like a cause and effect correlation, but instead what we could actually have is that there's a common cause. So maybe good weather. So good weather can cause more people to go to the beach, and good weather can cause a better tomato harvest. Therefore, there's that common cause. Okay, reverse cause and effect relationship. This is when the dependent and independent variables are reversed, it should be in the process of establishing causality. So for example, suppose that a researcher observes a positive linear correlation between the amount of coffee consumed by a group of medical students and their level of anxiety. Well, you could theorize that drinking coffee causes nervousness, but instead you could find that nervous people are more likely to drink coffee. So it could be like the reverse. Two more for the explanations. So it could be an accidental relationship. This is a correlation exists without any causal relationship between variables. Here's an example. The number of females enrolled in an undergraduate engineering program and the number of reality television shows on TV. You can have those both increase for several years, but it doesn't mean that they're actually related. It could just be a coincidence. So even though the number of females enrolled increases, the number of reality shows increases, it's a positive linear correlation, there's actually no relationship. It's just an accidental. Okay, and the last one, presumed relationships. A correlation does not seem to be accidental, even though no cause and effect relationship or common cause factors appear. Okay, so suppose you found a correlation between people's level of fitness and the number of adventure movies they watched. Okay, you can almost like assume, like it's totally logical that a physically fit person might prefer adventure movies, right? Maybe somebody that does like a Tough Mudder race or obstacle courses. Maybe they like adventure movies because they see the same type of idea in those adventure movies, but it's actually very difficult to find a common cause for these two or to prove that one variable actually affects the other. So it's just a presumed relationship.